If you want to see more topics, then check the playlist section of this channel. Also, if you want to buy my notes, then check the link in the description below. In this video, we will see an example on sinusoidal steady state analysis, nodal analysis. Question: use nodal analysis to find current I/O in the circuit of figure. Here for this circuit, we have to find the value of this current I/O by using nodal analysis. Let Is is equal to 6 cos 200t plus 15 degree ampere. The value of this Is is given. So first of all, we will take this circuit from here. Now, as we can see, these components are given in time domain. So we will convert this into its equivalent phasor domain. Convert time domain into phasor domain. Now this Is will change to capital Is. The value of Is is given, it is this much. Let's copy it from here directly. So this will be changed to 6 at an angle 15 degree, because if we compare this with standard expression, it is Im or small I is equal to Im cos omega t plus phi. So here the value of omega is equal to 200 radian per second. Phi value is this 15 degree and Im value is 6. Again its unit will be ampere. Then next is 20 ohm. So this 20 ohm will remain same in both time domain and in phasor domain also it will remain same. Then this VO, small VO will change to capital VO. Then this 50 microfarad. So 50 microfarad will change to 1 upon j omega c. So 1 upon j into omega value is 200. So 200 multiplied with capacitance value is 50 microfarad. So 50 into 10 to the power minus 6. One upon j into 200 into 50 into 10 to the power minus 6. So it is minus 100j ohm. Then next 100 millihenry. So 100 millihenry will change to j omega L. So j into omega value is 200. So 200 multiplied with inductance value is 100 into 10 to the power minus 3. So if we calculate this, so it will be j into 200 into 100 into 10 to the power minus 3. So it is 20j ohm. Then next this 40 ohm will remain same. 40 ohm. This will remain same. Then next is this small I/O will change to capital I/O. Small I/O will change to capital I/O. Then next is 0.1 VO. So this VO will change to capital VO. Now again, let's take this circuit and change these values. So let's take the circuit from here and let's replace all the values from time domain to phasor domain. So this IS will change to, here we can see IS, the value of IS is given, it is this much. So it will be, this is the value of IS, it will change to 6 at an angle 15 degree. 6 at an angle 15 degree ampere. This 20 ohm will remain same. This small VO will change to capital VO. 50 microfarad will change to 50 microfarad will change to minus 100 J ohm. Minus 100 J ohm. This 100 millihenry will change to 20 J ohm. 20 J ohm. This 40 ohm will remain same. This small IO will change to capital IO. This small VO will change to capital VO. So now we got this circuit in phasor domain. Now let's say this is node 1 V1 and this is node 2 V2. And let's say this is the reference node or ground node with 0 voltage. So all the currents towards this reference node. Let's say this is current I1, this is current I2, this is current I3. So now we will apply KCL at node V1. So let's apply KCL at node V1. So here we can see, according to Kirchhoff's current law, summation of all the currents entering a node is equal to summation of all the currents leaving the node. Now at this node the entering current is, this current is entering 6 at an angle 15 degree. 6 at an angle 15 degree is the entering current, then plus again this 0.1 VO, this is also a current, so it is entering 0.1 VO. Only these two currents are the entering current at this node. Then is equal to, now leaving current. So leaving current at this node is I1. Here we can see this is a single node. This whole forms a single node. So this I1 is the leaving current. I1 is the leaving current. Then next this I2 is also leaving current. So plus I2. Then plus this IO is also leaving current. So plus IO. Now let's write these currents in voltage form. So 6 at an angle 15 degree plus 0.1. Now this VO is, here we can see VO is equal to simply V1. Here we can write VO is equal to V1. So here this will be V1. Then is equal to, now this I1 in voltage form will be V1 minus 0 divided by 20. V1 minus 0 divided by 20, then plus I2. So I2 will be V1 minus 0 divided by minus 100 J. V1 minus 0 divided by minus 100 J. Then plus IO. So this IO will be V1 minus V2 divided by 40. V1 minus V2 divided by 40. Now let's take this V1, 0.V1 on right side. So 6 at an angle 15 degree is equal to, also here we can take this V1 common, or first let's take this on right side. So it will be V1 divided by 20 plus, let's copy it from here directly. Now let's take this on right side, so it will be minus 0.1 V1. Now again 6 at an angle 15 degree is equal to, we can take this V1 common. So if we take this V1 common, then the remaining part will be 1 by 20, then 1 by minus 100J, then minus 0.1, then here this will be 1 by 40. So plus 1 by 40. Here we can separate this 40. This will be V1 by 40 and this will be V2 by 40. So now it will be 1 by 40. Then next this V2. So simply we can write V2 as minus 1 by 40 V2. So 1, 2, 3, 4. 1, 2, 3, 4. So now again let's simplify this. 6 at an angle 15 degree is equal to V1 in bracket 1 by 20 plus 1 upon minus 100 into J minus 0.1 plus 1 upon 40. So it is minus 0.025 plus 0.01 J minus 1 upon 40. This 1 upon 40 can be written as 1 divided by 40 is equal to 0.025. 0.025 V2. Let's say this is equation number 1. Now we got equation number 1. Next, let's apply KCL at node V2. So apply KCL at node V2. Again, according to Kirchhoff's current law, summation of all the currents entering a node is equal to summation of all the currents leaving the node. So here at this node the entering current is, this IO is the entering current. So IO is equal to leaving current, this 0.1 VO and this I3. These two currents are the leaving current. 0.1 VO, 0.1 VO plus I3. Now let's write this IO in voltage form. So IO in voltage form will be V1 minus V2 divided by 40. V1 minus V2 divided by 40 is equal to 0.1. Now VO is equal to, here we can see VO is equal to V1. So V1 then plus, now in place of I3. So I3 will be V2 minus 0 divided by 20J. V2 minus 0 divided by 20J. Now let's simplify this. So it will be V1 divided by 40 minus V2 divided by 40. Then if we take this on left side, so it will be minus 0.1 V1 and this will be minus V2 divided by 20J is equal to 0. Now here we can take this V1 common. So V1 in bracket 1 by 40, then minus 0.1, 1 by 40 minus 0.1, then plus, if we take this V2 common, then it will be minus 1 by 40, minus 1 by 40, then minus 1 by 20J is equal to 0. So V1 in bracket, this will be 1 by 40 1 by 40 minus 0.1. So it is minus 0.75, minus 0.075, then plus V2 in bracket minus 1 by 40 minus 1 by 20 into J, minus 1 by 40 minus 1 by 20 into J, it is minus 0.025, minus 0.025 minus, not minus, plus 0.05 J is equal to 0. Let's say this is equation number 2. So now we got two equations, equation 1 and equation 2. So let's write this in matrix form. Write this in matrix. So we have to find the value of delta. First we will write this in matrix form. So from equation 1 it will be, let's take this V1 component, then from equation 2 V1 component is this, then next minus 0.025, then from here, from equation 2 this, then this will be V1 and this will be V2 is equal to, from equation 1 it is equal to 6 at an angle 15 degree, 6 at an angle 15 degree, and from equation 2 it is equal to 0. Now let's find the value of delta. So delta is equal to, we have to take the determinant of this matrix. So we have to take its determinant. So this is the determinant. So this into this minus this into this. So let's take it from here directly. This multiplied with this, then minus 0.025, minus 0.025 multiplied with this. minus 0.075 minus 0.075. So if we solve this, we get the value of delta. Let's solve this in calculator. Minus 0.025 plus 0.01 into j multiplied with minus 0.025 plus 0.05 into j minus 0.025 multiplied with minus 0.075. Now it is equal to this much, minus 1.75 into 10 to the power minus 1.75 into 10 to the power minus 3 minus 1.5 into 10 to the power minus 3 j. Now we got the value of delta. Next we have to find the value of delta 1. So to get the value of delta 1, we have to replace the first column with this value, 6 at an angle 15 degree, 6 at an angle 15 degree, 0, and this column will remain same. So minus 0.025 minus 0.025 and this will remain same. So let's take it from here. So this into this minus this into this. So 6 at an angle 15 degree multiplied with minus 0.025 plus 0.005 j. 6 at an angle 15 degree multiplied with this, then minus 0. 6 at an angle 15 multiplied with minus 0.025 plus 0.05 into j. 6 at an angle 15 degree multiplied with minus 0.025 plus 0.05 into j, it is equal to minus 0.2225, then plus 0.250, 0.2509 j. So this is the value of delta 1. Next, the value of delta 2. So for delta 2, first column will remain same like this. Let's take this matrix from here directly. But this second column will change and these values will be 6 at an angle 15 degree, 0. 6 at an angle 15 degree, 0. So this into this will be 0 minus this into this. So minus 0.075 multiplied with 6 at an angle 15 degree. So it is equal to, let's solve this in calculator, minus 0 minus 0.075 multiplied with 6 at an angle 15, it is equal to 0.434. 0.434 0.434 plus 0.116 j. So this is the value of delta 2. Now we got the value of delta, delta 1 and delta 2. So we can easily find the value of V1. So V1 is simply delta 1 divided by delta. So the value of delta 1 is this. This is the value of delta 1 and the value of delta is this. So let's take this value. So V1 is equal to minus 0.2225 plus 0.2509 into j divided by minus 1.75 into 10 to the power minus 3 minus 1.5 into 10 to the power minus 3 into j. So it is equal to this much, 2.25, 2.45, then minus 145.47 j. So this is the value of V1. Now this value is in rectangular form. In polar form, this will be shift to 3. So it is equal to 145.49. 145.49 at an angle minus 89.03. Minus 89.03 degree volt. This is the value of V1. Next, we have to find the value of V2. So V2 will be delta 2 divided by delta. So the value of delta 2 is, this is the value of delta 2. Delta 2 divided by the value of delta is this. So this is the value of delta. If we solve this, we get the value of V2. So let's solve this. 0.434 plus 0.116 into j divided by minus 1.75 into 10 to the power minus 3 minus 1.5 into 10 to the power minus 3 into j. It is equal to this much. In rectangular form, in polar form, this will be shift to 3. So it is simply 194.90, 194.90 at an angle 154.36, 154.36 degree volt. Now we got the value of V1 and V2, but here in this problem, we have to find the value of IO. So IO is equal to here we can see IO is equal to V1 minus V2 divided by 40. This IO is equal to V1 minus V2 divided by 40. V1 minus V2 divided by 40. So V1 value is, this value is the value of V1. So V1 minus V2. This is the value of V2. V1 minus V2 divided by 40. It is equal to 145.49 at an angle minus 89.03 minus 194.90 at an angle 154.36 divided by 40. So it is equal to this much in rectangular form. In polar form this will be shift 2 3. So it is 7.26 at an angle minus 52.21 degree, and since it is current, so its unit will be ampere. 7.26 at an angle minus 52.21 degree. Now this is in phasor domain. In time domain it will be IO is equal to IM cos omega t. Simply small I is equal to IM cos omega t plus phi. So we have to find the value of IO. So IO is equal to IM value is 7.26 cos. Now the value of omega, here we can see the value of omega is 200. So 200 t plus phi value is minus 52.21 degree. So 7.26 cos 200 t minus 52.21 degree, and since it is current, so its unit will be ampere. So in this problem, what we have to find? We have to find the value of this IO by using nodal analysis. So this is how we can find the value of IO by using nodal analysis. Don't forget to check out the other videos on this channel, and thanks for watching.